Okay, I'm going to be going over determining whether a function is even or odd, which corresponds to this page in your course manual. So I'm just going to do the subheading really quick just so you can kind of see what it means for something to be even, what it means for something to be odd. So for the, it's not a good marker. Okay, so for the example that we're given for the even function, we're given a quadratic which is symmetric about the y-axis. So you can see, and why is this? Because, again, make your table forever, sure, x and y, and our function is y is equal to x squared. Let's plug in 1. So y is equal to 1 squared is equal to 1, y is equal to 2 squared. So x squared, so 2 squared is equal to 4. If our x value is 3, 3 squared is equal to 9, and so on. Sorry, so if you plot those points, you have 1, 1, 2, and 4, and 3 and 9, something like this. Now, you also have your negative values. So this is, sorry, I'm going to write it as a function. So f of x is equal to x squared. Well, what happens if we plug in f of negative x? We also get x squared. Why is this? Because a negative times a negative makes a positive. So negative x times negative x, 1, 1. Those negative signs cancel. You're left with x squared. So we can also test this by plugging in negative versions of these values. So x, again, y. So f of negative x is equal to negative 1 squared. I'm going to move this back a little bit. So yeah, f of negative x, so instead of positive 1, we're doing negative 1. So when x is negative 1, y is positive 1. F of negative 2, negative 2 times negative 2 is equal to positive 4, and so on. So negative times a negative, as we know, gives us a positive number. So if we plug in negative 1, which is f of negative x, we get positive 1. So negative 1 and 1. If we plug in negative 2, we got 4, because negative 2 times negative 2 is equal to positive 4. Negative 2, 4. Negative 3, 9. So as you can see here, your y values are identical if you have f of x and f of negative x. So positive 1 and negative 1 both give you a y value of 1. Positive 2 and negative 2 both give you a value of 4. Positive 3 and negative 3 both give you a value of 9. So since our y values are identical, we would say that this is an even function. This basic quadratic example here, even function that is symmetric about the y-axis. This is how they're going to want you to write that on the exam. So even function symmetric about the y-axis. Now let's take a look at what an odd function would look like. So a good example of an odd function would be a trinomial, which is f of x is equal to x cubed. So here we had x squared, which is 2 is even. So if you take negative x, f of negative x times negative x, you get positive x squared. But if you have a trinomial, you have negative x times negative x. Again, we're rewriting this as f of negative x now. So that's how we're testing if it's symmetric. It's going to be negative x cubed. So f of x is equal to x cubed, f of negative x is equal to negative x times negative x times negative x. So negative times a negative is a positive, but you also have this negative right here, so you have negative. So f of x is not equal to f of negative x. It's equal in value, opposite in magnitude. So this means this is positive, but this is negative. So what does that mean? In simple language here, if we draw the graph of a trinomial, again, let's plug in our values now and make a simple table of x and y. So our simple function is f of x is equal to x cubed. So let's plug in 1 cubed. So 1 cubed is just 1. 2 cubed, so it's 2 times 2 times 2 is 8. 3 cubed is 3 times 3 times 3 is 27. This would correspond to something like 1, 1, 2, 8, and so on. So now, this is our f of x function. What if we plug in f of negative x is equal to negative x cubed? So again, we make our simple table, but now for our negative values. So negative 1, that's the negative version of x, which is, we have positive 1, we're doing negative 1. Negative 1 cubed is negative 1 times negative 1 times negative 1, which is going to give us a negative 1. All right? Negative 2 times negative 2 is positive 4 times negative 2 is going to give us negative 8. So you should be seeing a little bit of pattern here. So negative 3 times negative 3 is positive 9 times negative 3 equals negative 27. So here we have, when x was 1, we had a y of 1. When x is negative 1, we have y as negative 1. When x is positive 2, we had a y value of 8. When x is negative 2, we had a negative version. So we're always looking at what our y values are doing. So they're the same value, but they're opposite in magnitude, which means that, so at x of negative 1, we had, again, negative 1. X of negative 2, we had negative 8. So we would say that this is symmetric about the origin, because again, same value, but opposite in magnitude. So it's not symmetric about the y-axis because they're not the same value, but they are opposite in magnitude. So now we can apply this to our practice problem. Just keep that all in mind. Okay. Our first example is f of x is equal to x fifth plus x. So f of x is equal to x fifth plus x. In order to test if something is symmetric, we plug in the negative version of that. So f of negative x is equal to negative x. I just like to do parentheses to keep it simple for myself. Negative x to the fifth plus x. So if you want to write it out, you can, but I see that f is an odd number. Whenever we have an odd number, we're going to have a negative value. So negative times a negative, again, positive, positive, negative. So we have negative x fifth, and then plug in that negative x plus negative x. So f of x is equal to x fifth plus x, but when we did f of negative x, we got negative x to the fifth minus x, so which is not equal to f of negative x, because again, as we said, it's equal to negative x to the fifth minus x. But what do we see? Here's a positive sign, here's a positive sign, here's a negative sign, here's a negative sign. So that means they're opposite in magnitude. So since it's the same formulas, but opposite signs, we know it's going to be symmetric about the origin. We said this is an odd function. So rule of thumb is just whenever you have like negative x to an odd power, you know that your value is going to be negative. Whenever you have your negative version of x with a even exponent, you're going to get a positive x value. And that's just because a negative times a negative times a negative, again, if we have it 3 times, like a simple example, negative times a negative is positive, times a negative is equal to a negative, versus a negative times a negative is equal to a positive in the case of x squared. So we would say that this one is symmetric about the origin, and it's an odd function. Okay. Our next example is g of x is equal to 1 minus x fourth. Again, we're going to plug in our negative x. G of negative x is equal to 1 minus, we plug in our negative x into here, and fourth. So 1 minus, and again, you always just input it indirectly for that x, so don't touch any of the signs of the original equation. So again, you see this is a even exponent, which tells us that this value is going to be positive x fourth. So g of negative x is equal to 1 minus positive x fourth, which if we look at our original equation, g of regular x is equal to 1 minus x fourth. So these equations are identical, which tells us that our function is symmetric about the y-axis because our y values are going to be the same at every value of x. So if I do 1 minus 1/4, I get, that's a bad example. Yeah, we can do that. 1 minus 1/4 when x is 1. 1 minus 1 is equal to 0. 1 minus negative 1/4, so again, 1 minus 1 is equal to 0. The same exact value. So when x is 1, y is equal to 0. When x is negative 1, y is still equal to 0. So we would say that our y values are exactly the same. This works because they're the same exact function. And then the last example is a little bit trickier. So we have h of x is equal to 2x minus x squared. So again, we plug in our negative x, h to the negative x is equal to 2, again, plug in our negative x minus, again, don't touch those signs, just plug it in for x, negative x squared. So this is even, which tells us that this is going to change to positive. Negative times a negative equals a positive x squared. Just drop this down, negative 2x, drop that negative sign down, negative 2x minus x squared. So this does not match our original equation, so we can automatically rule out this is not an even function. Well, it's an odd function. It's also not an odd function because in order for it to be an odd function, it would have to have opposite signs to our original equation. So if it were an odd function, h of negative x would be negative 2x plus x squared, which is not equivalent to the equation that we got. We got negative 2x minus x squared, which is not opposite in magnitude to this one because we have a positive and a negative. So in theory, we should have a negative and a positive. So the signs would have flipped in our odd function, but they didn't, which tells me that this function is neither symmetric about the x-axis or symmetric about y-axis. So now you've seen like every scenario, an even function, an odd function, and a situation where it's neither.